learn about what is CFG in NLP. Okay, so CFG is context-free grammar. You must have learned this in a TOC in a very different way, but CFG in NLP also is there. So you can see that the CFG is a set of rules. Okay, so basically it is a set of rules which is helping you to create some combination of, you can say, pattern in TOC. In same way, CFG here helping you in the same way, just to check a parsing. You can call it as a checking of grammar. Okay. So what exactly CFG means? So CFG is a type of grammar used in NLP to describe the structure of sentences in a language. So it is used for understanding a sentence formation, checking whether the statement is grammatically correct or not, and also helps you to build a parsers for the NLP. So these are the parsers are the main component because this is a just second step. First step is the lexical analysis, second is the syntactic analysis. In syntactic analysis, you need to check the grammar. Okay, so same as learn, you have learned in a TOC, it has a four components. Okay, the four components are, if you remember, the four components are terminal, non-terminal, start symbol, and roots. So you also here have these elements N, T, P, S. Okay, so NTPS, what it does? The terminal one. So terminal, what it does? It has a terminal symbol. So for example, these are the actual words. For example, in any statement you get dog, cat, girl. Okay, actual word that you can replace. Okay, so these are the final symbol. There is no more. You can say decoding of that particular word or the you can say dividing of that particular. That is a terminal symbol. Okay. P is a rules. If you are setting a rules, for example, S is equal to NPVP. So this is a rule. So if I want to replace a start symbol, I will replace it with NPVP. So there is a one rule called as a VP is equal to verb VP. If I want to replace a VP, I'll be replacing with a verb VP rule. Okay, so these are the production rules. And the S, you know that that's the start symbol. Okay, so anyway, you are starting your statement from a S, that's the start symbol. Okay, and N is the non-terminal symbols. Okay, so you know that the non-terminal symbols helps you to derive the statements. Okay, so that could be sentence, noun phrase, verb phrase. Okay, so that you can divide it further. Okay, so that is the you can say non-terminal one. Why it is called as a CFG? Because they don't care about the context, they only care about the grammar. Okay, so they are not worried about semantic analysis. That is a task of semantic analysis. In syntactic analysis, you only care about the grammar only. Okay, so this is just one of the example you must have learned in a TOC. Okay, so you got this kind of symbols, you got this kind of rules, and you have created some patterns, right? So in case of derivation tree, in same way, the derivation tree, you call it as a context-free tree, or you can call it as a parse tree. So when you are drawing any parsing tree, you have to start with the roots vertex. You can see the root symbol, and that root is always a start symbol. So whatever tree you are drawing, whatever the roots are there, the S will be your root vertex. Okay, and the leaves will be the terminal. Okay, and that in between nodes will be the non-terminal symbols. Okay, so you can have a two ways to do that. One is a top down, another way is a bottom up. The one and the basic one is this top down approach. But for what? To check a grammar. So when you're getting any numerical or example, you're getting those rules, you're getting those terminal, non-terminal symbols, and you will be asked, this is a statement, do the top down parsing. This is a statement, do the bottom up parsing. Okay. So as name says top down, it will start from a S, start symbol, bottom up, it starts from a leaves to the root node. Okay, so this is a very basic example of CFG. This is one example we are going to see. So you got this terminal symbols, okay, you got the non-terminal symbols, you got the start symbol, you got the rules. Okay. So in any question you'll be given all this already. Okay, so you'll be given a production rules, you'll be given non-terminal, you have to know the what is to be replaced with what case. Also you'll be given some statement. Okay, so for example, in this case, this is your example, this is your statement. So for example, if you're given a statement, the man read this book, and you will be asked like, do the top-down approach, generate a tree, and tell it is correct or not grammatically. So for that, you have to start with the A's only. So you must have A's on the left-hand side. That RHS will be increasing, but your left will be the A's only. Okay, so I'll be see in this case I having a three choices. Many times you won't get this searches. You will have only S rule, so you are anyway going to by default use that rule. But in case you got multiple rules, like in this case you got a three rules for a symbol, you have to make a choice from where I will start. Okay. So in this case, since you know already you're not a machine, you know already what should be the rule going there, but what machine does, machine will try every rule. They will try to create that statement. If it is not happening with by any rule, it will show you that is a grammatically incorrect. But as a human, we know that what is the rule? What will the rule? SP is equal to NP because the statement is the man read this book. So it is a combination of noun phrase also and verb phrase also. So I chose the rule NP. So now what is NP? I have to replace because that is not a non-terminal one. So what are the rules for NP? I see only one. So I'll be replacing that DAT now. Okay. So in case of top-down parsing, you don't have to replace multiple words in a single line. In single line, you're replacing only one non-terminal or you're replacing only one variable. So if you can see that we only replace the over here. You are not replacing NOM or VP. You are not looking for that. You are just creating one word at a one point of time. Otherwise, your answer will be ended in two or three lines. Okay, that should not happen. Okay, so I replace DET. Do I have a choice for DET? Yes, I got a choices. That is the. But what I given in example, the. So I'll be replacing DET as a the. NOM VP as it is. Copy paste. Okay. What is the replacement for NOM? Do I see replacements? I got a two choices. So it is up to me what choice I should I choose. If I see that the I got a man. After the, I got a man in example. So I'll be choosing this. The man reads this book is already given in your example. Okay. We are just deriving it over here. So the NOM will be replaced as a noun. What are the noun? Book, flight, meal, man. So what I have to choose? A man. Okay. The man, VP. Okay. That VP will be replaced. I got a rule for VP. Yes, I got a two rules. I'll be choosing verb NP5 because I also have one noun ending. So only verb won't work. So I will be choosing verb NP. So I'll be choosing verb NP. So verb will be replaced by the read because this is my statement only. NP, I got two choices for NP. Only one choice is DET NOM. DET replaced with the this, NOM replaced with the noun, and now replaced with the book. This is how you do top-down parsing. So what will the conclusion of this particular question? It is grammatically correct. But answer should not end over here. Whether you're being asked or not, you're supposed to draw a tree like this, a past tree. Okay, so you're checking the rules first, then you're drawing tree later. So you don't have to draw tree first and then write down the rules. You must write the rules first, then you draw a tree. So whatever you have replaced, that is just drawn over here. So first rule was NPVP. Okay, then you deal with the NP part. Then you look for an NP rule, DT and then you replace DT with the. So if you go from left to right now, you will just exactly find the statement. The man read this book. This is how the statement is happening. So your tree must create a statement from left to right. This is what we call top-down parsing. Okay, so these are just examples of top-down parsing. Okay, this is one of the examples. So sometimes you got a multiple rules. You have to choose that. For example, does the man read the book? You will give a sentence. You just have to replace those words like this. Okay. So now after that, there is another thing is a bottom-up parsing. But why bottom-up parsing? What is the problem with the top-down parsing? Since the rules, for example, that LHS and RHS, the LHS will be same, but RHS will be different. So you will go into the recursion. So you might be going in a loop without getting actual answer. So for that reason, you do the opposite thing. You will be shift and reducing. That is the bottom up parsing. So you will be starting from a root. So you will be starting from a leaf and you will reach to the root. If you're reaching to the root, then that is a grammatically correct. So this is somehow a little bit difficult and top down, but it is also one of the method to check a grammar. Okay, so for example, this is the grammar you have been given and you have been given a statement, book that flight. So you're being asked, book that flight, check for bottom-up parsing. See, so what you do in a bottom-up parsing, you do the shifting part, you shift the terminal input symbol, okay? You reduce it to the sum, you can say basic version that is given in a rule, and then you parse. So if you see, as an example, book that flight. Okay, so that is my input statement. So when you're drawing a table for shape reduce parsing, these three column heads must be correct. Okay, you can't be randomly writing anything over here. The first should be a stack. Okay, you must have done that in a data structure. Okay, that infix postfix in the same way. Stack, input, action. Okay, so what will the stack? First, it will be empty one. Okay, the input will be the book that flight. What is the action is happening? The first action is always a shifting one. Okay, because you haven't got any inputs. So you'll be shifting. So only one token shifted at once. So what is shifted? Book. Okay. So I shifted a one token. That's a book. What is remaining here? That flight. Can I reduce book? Yes, I can reduce book to the verb. I got choices. If you can see that I have two choices for book. One is a verb, one is a noun. But in bottom-up parsing, you can make a choice. Since we are solving it manually, we are making a choice as a book. But in case of machine, it look for both choices. If it is choosing as a noun, if it doesn't get a success, it will look for another choice. Okay, until it get a success. If both rules are not satisfied, it will show it is false or it is not correct. Okay, so we chose book as a verb. So I shifted this book as a verb. Okay. So in stack, I got this book as a verb. The input is remaining same. Okay. Now what will the command shift? See, whatever command you are giving, that should be come first and then output should reflect here. Okay. You should not say shift and you should not write here that. Okay. Shifting will write as an action first, then the shifting will happen in a next statement. Okay, so you should not forget about this. Okay, shift I said first, then that will be shifted. Okay, in that particular after shifting, I'll be looking for a reduce rule. Okay, so that verb plus that I don't have any rule, so I have to make sure that that should be replaced with some symbol. So that is a det. So determiner. So verb determiner flight as it is. Now I will be doing a shifting part. Okay. So in this case, you have a choice. Either you shift a flight. Okay, either you reduce a verb deity rule. Okay, so if you don't find verb deity rule, then you can go for a shifting. So since I don't have any verb deity rule over here, okay, I'll be going for a again shifting. So I'll be shifting third word flight. So verb deity flight, nothing on input, reduce. Can I reduce flight as a noun? Yes, I reduce it is as a noun. Okay, so nothing remain in a input. Okay, so again reduce. So since you don't have anything, you can't have a shifting. You can only do the reducing part. Okay, reduce, reduce. Okay, reduce noun, reduce nom as a noun. Rules are given like that. Okay. I got this combination verb det norm. Is there any kind of rule I see in a given rules? Yes, I see det norm replace should be as a NP. So I replace it as a NP. So that is a reduce verb NP. Okay, verb reduce. Okay. So until and unless you reduce it as a single start symbol, you can't say it's a success. So verb NP will be become as a verb. Okay, so s will be reduced as a verb, so finally you get a success. How? Because that s is equal to vp. Okay, verb will become vp and that s is equal to vp, so I finally reduce to the successful. So ambiguity, if there is ambiguity, you have to go backtrack and choose another rule, but since you got a success, you don't have to go for a choice number two. This is how the shift reduce parsing happens. Okay. So this is another statement. The dog chased the cat. You started, you shifted. Okay. You shifting one by one. Okay. And you finally get a success. That is a NP verb det cat noun. So NP verb det noun. So you'll be choosing what to reduce. So you are choosing reducing for det noun NP, then NP VP and then S. So here the input has to become in the middle. Action should be on the this side and this is shifting. When you say shifting, then once what has to be shifted in the next statement. This is how the you can say bottom-up parsing will happen. Okay, but sometimes you will not get any answer. These are just example. Okay.